Welcome to today's lesson on continuous deployment, or CD. In the fast-paced world of technology, getting your code from development to users quickly and reliably is paramount. Today, we're going to demystify continuous deployment and equip you with the knowledge to build robust, automated systems. By the end of this session, you'll have a clear understanding of several critical concepts. You'll be able to explain multi-environment deployment strategies, like moving code from staging to production seamlessly. You'll also understand how to implement zero-downtime deployments using techniques like blue-green deployment. Furthermore, we'll cover the importance of automated rollback mechanisms to ensure system stability and how to handle complex database migrations safely within a CD pipeline. Finally, you'll grasp the integration of health checks and monitoring to keep your systems running smoothly. Let's dive in. So, why are CD pipelines so crucial in today's landscape? Imagine companies like a large social network or a major streaming service deploying updates thousands of times a day. This isn't just about speed, it's about reducing risk. Smaller, more frequent deployments are inherently less risky than large, infrequent ones, making it easier to isolate and fix issues. For your quiz platform, this means no more dreaded 2-hour maintenance windows that disrupt students during exams. CD pipelines enable zero-downtime deployments, ensuring continuous availability and reliability. But how are these powerful pipelines structured? Our CD pipeline extends the continuous integration workflow you might already be familiar with. After CI successfully builds and tests your code, the CD process kicks in. Key components include artifact packaging, where your code is turned into deployable units like Docker images. Then there's environment promotion, moving code from a testing environment, like staging, to the live production environment. Critical for zero downtime is the blue-green deployment strategy, which we'll explore in detail. And finally, robust health validation, which triggers automated rollbacks if anything goes wrong. These components work together to create a bulletproof deployment system. Let's walk through the actual deployment flow, stage by stage, once your continuous integration build is successful. The first step, environment preparation, is where the pipeline takes the validated CI build and prepares it for deployment. This means creating and tagging Docker images with the correct versions and injecting any environment-specific configurations needed for staging or production. This ensures that your application behaves exactly as expected in each environment. Next comes the blue-green switch, which is where the magic of zero downtime happens. We maintain two identical environments, blue and green. One is active, serving live traffic, while the other is idle. When a new version is deployed, it goes to the idle environment. Only after it passes a series of rigorous health checks does the load balancer switch traffic to the newly deployed, now green, environment. The old blue environment remains as a safe rollback option. Finally, we reach production rollout. Production deployments typically require a manual approval step, a human gate to prevent accidental releases. This stage also runs comprehensive health checks, often more stringent than those in staging, before fully accepting live traffic. If any of these checks fail, an automatic rollback is triggered, instantly reverting to the previous stable version, minimizing any impact on users. Managing the state of your deployments is crucial for clarity and control. Every deployment follows a strict state machine, providing transparency into its current status. It begins in a pending state, awaiting its turn. Once initiated, it moves to deploying, indicating active deployment. After the deployment is complete, it enters validating, where health checks are running to ensure everything is stable. If all checks pass, it transitions to active, successfully serving traffic. Should any issues arise, it quickly moves into a rollback state, initiating emergency restoration to the previous stable version. Now, the trickiest part of continuous deployment often involves handling database changes. This is where many pipelines falter. our strategy is to implement forward-compatible migrations. This means your database changes are designed to work with both the old and the new code versions simultaneously during the deployment window. For simple additions, like adding a new column, it's straightforward. The old code simply ignores the new column while the new code starts using it. Removing a column, however, requires a two-phase deployment. First, you deploy code that stops using the column but doesn't remove it from the database. In a subsequent release, after the first phase is stable, you deploy code that drops the column from the database. This meticulous approach ensures your database never breaks during the deployment process, maintaining data integrity and system uptime. A robust CD pipeline doesn't operate in a vacuum. It integrates seamlessly with various essential tools and services to form a complete ecosystem. For monitoring, tools like Datadog or Prometheus are crucial for collecting health metrics, giving you real-time insights into your system's performance and stability. Secrets management, handled by services like Azure Key Vault, ensures sensitive information like API keys are securely stored and accessed only when needed, preventing hardcoding and exposure. Load balancers like Nginx are vital for traffic routing, directing user requests to the correct instances and facilitating those zero-downtime blue-green switches we discussed. And of course, your database, like PostgreSQL, works in conjunction with your carefully crafted migration scripts to handle data evolution without disruption. Finally, effective environment configuration is key. Staging environments might run with debug mode enabled and lower rate limits for thorough testing, while production environments prioritize performance with higher rate limits and no debug features. This allows you to test under realistic but controlled conditions. And what happens when things inevitably go wrong? That's where automated rollback mechanisms become your ultimate safety net. Your system continuously monitors critical health endpoints. If any key metrics fall outside acceptable ranges, perhaps a sudden spike in errors or a drop in response time, the system automatically and instantly reverts to the last known stable version. This proactive approach dramatically minimizes the impact of unforeseen issues. By the end of this lesson, you should be able to appreciate the strategic importance of CD pipelines, understand the mechanics of blue-green deployments, recognize the necessity of automated rollbacks, and grasp how to manage complex database changes. As a self-assessment, consider this. How would you explain the benefit of a two-phase database migration to a non-technical stakeholder?